Well children, let us take some basic questions which has been there in CBSE board examination. First question is what is cause of quantization? So you see, what is the meaning of quantization? The meaning of quantized means what? Being fixed and definite. So what is the cause? Because in the process of charging, only one electron or two electron or three electron, that is means in whole number the electrons will be transferred from one body to another body. It's not possible that you transfer 2.5, 3.2. These electrons cannot be transferred. Either 3 electron will go or 4 electron will go. So that's what the reason of quantization. Since the whole number of electrons are transferred during the process of charging, therefore the charge is always quantized. Now look the next part. What at macroscopic level, why quantization of charge is ignored? So macroscopic level means what? At very large level. Why quantization is ignored? Because see, you are counting how many electrons have gone, and electron has got a very small amount of charge. So because the amount of charge that is possessed by one electron is very small, that's the reason it is ignored. So at large scale level, it doesn't matter that 1.6 into 10 to the power minus 19 coulomb, such a small charge is going to matter anything. Now next one, can a body have a charge equal to this much? So answer is again no. Why? How we adopt the process? So formula is Q equal to N into E. Q equal to this much, N value we have to find out, E value is equal to this much. Find the value of N. N will not come as a whole number, so this much charge exactly cannot be produced. It is always produced in discrete amount, but this value is not falling in that discrete series. Now next, what is the deficiency of electron? Once a body has plus 1 coulomb charge, simple, Q equal to N into E is the formula. Q equal to what? 1. N value we have to find out. E value is 1.6 into 10 to the power minus 19. Find the value of N. N will be what? 1 upon this much. 1 upon this much is equal to 6.25 into 10 to the power 18 electrons. Fine. Next one, is the mass of a body affected on charging? So yes, it is affected. How? If a body gets positive charge, it means that it has lost some electrons. So corresponding to the mass of electron, there will be mass decrease also. If a body has obtained negative charge, so that means it has received some electron. So corresponding to the mass of electron, its mass will also increase. If a tiny particle is given positive charge, does its mass decrease or increase? So answer is what? Because it has got positive charge, so its mass will decrease. Okay, that's next question. Previously we got the same question with another supplementary connotation. This time it is simple. What is the basic cause of quantization of charge? So listen, answer again taken, because total charge possessed by a body is integral multiple of fundamental charge. That means what? Only whole number of electrons can be transferred. They cannot be transferred. How? They cannot be transferred as what? 1 by 2 electron cannot be transferred, 3 by 2 electron cannot be transferred. So that's the cause of quantization. Okay, so now the next part. The vehicles carrying inflammable materials usually have metallic ropes touching the ground during the motion. You see that there is a cylinder which carries LPG, and this LPG, any inflammable material that is put inside, it is being dragged. It is connected by a metallic rope. The rope is dragging all along the motion. And why it is being done? So because the cylinder is consistently in the process of what? Air friction. This air friction causes what? Some amount of charge to get developed on the surface of cylinder. Now over a period of time, a high voltage is produced on its surface, and because this high voltage may get discharged in the surrounding by a process called as the corona discharge, so it may catch fire due to high voltage. That is why metallic ropes touching the ground is used, so that charge which is produced due to friction is transferred into the ground. That is the situation. Metallic rope will take all the charge to the ground by just as the process of earthing. But nowadays it is not a common practice. We are having a high quality of rubber in constructing, in designing the tire. So this process is by default. We won't have to look on for these primitive types of the idea. Now next one. A bird can sit on the bare high power line, but if a man is standing on the ground, touches the same line, gets a fatal shock. Why? So reason is what? If a bird is sitting on a high voltage line, immediately obtains a high potential. Okay, immediately the potential of the bird's body and the wire becomes equal, and it does not establishes any regular rate of flow of charge through its body. There is no current flow. But if a man who is standing on the ground and is touching high voltage line, this establishes a regular rate of flow of charge from the wire on the ground, and this is generating what? A regular flow of current that obstructs heartbeat, and this appears what? In the form of what? Fatal shock. Interesting. Now next question is what? Can a charged body attract uncharged body? So answer is yes. If this charged body is brought near to this body which is initially uncharged, and just bringing this body next to it is causing what? Polarization of charge in this body. This body and this corner gets polarized. What will happen? If these two are what? Polarized, so there is what? Force of attraction between these two bound charges. So let this be initially uncharged, but once this body is brought, so free electrons of this body are just being clustered to this side, and now these two bound charges are attracting one another. Now look this question. You are given three uncharged spherical conductors ABC. Initially these A, B, C were uncharged and they were touching one another. They were touching each other. A glass rod carrying a positive charge is brought near A. Yes, it is a glass rod. It is brought near A. What it will do? It will cause charging by induction. It will cause charging by induction. So now see, charging by induction has happened. So across this corner we are having negative charge, across this corner we are having positive charge, and now look, there is a process. Maximum corners distant apart, the positive and negative charges have emerged. Now what will happen? A is having negative charge, B is neutral, C is positively charged. That's what answer is. Nature of charge developed here. Now I just put on an additional question. I'm asking that as on date we have heard that positive and negative charges are attracting. Yes, they are attracting. That's why this negative charge has come. All free electrons has been transferred from C to B to then A. That's why this corner of A has turned negative. Now come on, tell me, in case positive negative attracts, so is it true only at this corner? Why you are placed here? Why don't you come and be here? Just next to this one. Even I don't want you to be at the corner of A. Here I don't want you to be. I want you to be strictly here. So why you are placed this far apart? So now to explain it, I just make today first explanation, first logic today I am taking, and then I'll take you to some other logics when I am taking you to the Gauss law. Look here, this explanation is, किसी बॉडी पर फोर्स उधर लगता है जिधर उसकी पोटेंशियल एनर्जी डिस्टेंस के साथ घटती हो. दैट इज व्हाट इट इज फंडामेंटल लॉ ऑफ फोर्स. किसी ऑब्जेक्ट पर फोर्स उधर लगता है जिधर उसकी पोटेंशियल एनर्जी डिस्टेंस के साथ घटती हो. दैट्स व्हाट अ सेंस ऑफ माइनस साइन. And that's the reason. Now look, what is the formula for potential energy of two charges? So this is the formula. This formula will be proved in the next lesson, or very shortly we'll prove it. The electrostatic potential energy for system of two charges, say Q1 and Q2, placed r distance apart, is given by this formula, and this shows that U is proportional to 1 upon r. That means what? Shorter is the value of r, bigger will be value of U. लेकिन फोर्स तो ऐसे लगता ही नहीं है. The force is acting in such a way कि डिस्टेंस के साथ पोटेंशियल एनर्जी घटनी चाहिए. तो ठीक है, डिस्टेंस बढ़ती है डिस्टेंस बढ़ती है, लुक दैट हैज हैपेंड हियर, डिस्टेंस बढ़ती है तो पोटेंशियल एनर्जी घटती है, एंड दिस ब्रिंग्स द सिस्टम इन स्टेबिलिटी. This brings the system in stability. Smaller is the potential energy, stable is the system. That's the reason. It is logic number 1. We'll look on logic number 2 sometime else. Polythene piece rubbed with the wool is found to have a negative charge 3.2 into 10 to the power minus 7 coulomb charge. Calculate number of electron transferred from wool to polythene. Okay, so Q equal to N into E. Q equal to N into E, and then you find the value of N, it is equal to this much. Now just next question, simple one. Next question is what? There are 3 charged bodies A, B and C. A, B and C. A and B as well as A and C repel each other. If A and B repel each other, let me just take it once more. If A and B repel each other, so it means that they must have same charge, they must have like charge. If A and C also repel each other, A and C also repel each other, it means what? A and C must also have some same like charge. So A is having same charge as B has, A has same charge as C has, so B and C will also have same charge, so they will repel each other. Good. But is it always true? No. It is always true? No. What is the condition? The condition is B को C के पास लेकर के आते हैं, so the amount of charge that B has should not be in a position to cause any polarization here. अगर B ने C को polarize कर दिया तो B C repel नहीं करेंगे, repel नहीं करेंगे. So this answer is not complete. You have to mention subjected to the condition B cannot polarize C. And vice versa, C भी A को B को polarize ना कर दे. So because in that condition कि इन दोनों पे like होता रहे, तब भी B और C एक दूसरे को attract कर ही लेंगे. Very soon we'll be discussing what Coulomb's law.